November 22nd, 1922, in the quiet farming community of Gosport, a boy named Eugene Morrison Stoner was born at a moment when America stood on the edge of upheaval. Within a few years, the Great Depression would devastate the economy, and global war would follow. Nothing in his modest beginnings suggested that he would one day influence modern warfare. Stoner grew up in a household shaped by financial hardship. College was never a realistic path. After finishing high school in 1939, while many classmates left for universities, he sought employment instead. He found it at the Vega Aircraft Company in California, installing weapon systems on training aircraft. The work demanded technical precision and mechanical intuition. More importantly, it introduced him to aircraft-grade aluminum, a material rarely considered suitable for firearms at the time. For generations, gunmakers had relied on steel and wood. Steel offered strength but added weight. Wood was traditional but vulnerable to moisture and environmental damage. Aluminum, by contrast, was lightweight and corrosion-resistant. Properly engineered, it could withstand significant mechanical stress. Yet previous attempts to build a combat rifle from aluminum had failed, reinforcing the widespread belief that such an approach was impractical. Stoner took note of that assumption. After the attack on Pearl Harbor on December 7, 1941, Stoner enlisted in the United States Marine Corps. Experiences shaped his thinking. In spare moments after maintenance duties, he drafted alternative mechanisms in notebooks, simplified gas systems, revised bolt assemblies, and straight-line stock designs intended to redirect recoil more efficiently. By 1943, he had constructed experimental .30 caliber carbine concepts in his own time. They were incomplete, but they contained ideas that would later define his work: reduced moving mass, modular components for easier field maintenance, and recoil management through inline geometry. His approach was systematic rather than speculative, rooted in practical observation. When the war ended in 1945, the 22-year-old veteran returned to California and entered civilian manufacturing. At Whitaker, an aircraft components company, he began on the shop floor. His aptitude for precision machining soon led to a design engineering role. There, he refined techniques for working aluminum to exact tolerances suitable for high-stress mechanical systems. That expertise would later prove decisive. Throughout the late 1940s and early 1950s, Stoner continued firearm design as a private pursuit, building prototypes in his garage. Industry experts occasionally expressed interest, but established manufacturers hesitated to finance production. The prevailing view within the United States Army Ordnance Corps, including officials in the United States Army Ordnance Corps, held that a lightweight automatic rifle powerful enough for long-range effectiveness could not be achieved without sacrificing durability. For Stoner, the position aligned perfectly with years of independent experimentation. He had questioned conventional assumptions about weight, materials, and recoil management. Now he would have the institutional platform to test those ideas. Ideas that would soon redefine the modern military rifle and influence infantry doctrine worldwide. The opportunity seemed tailor-made for a largely self-taught firearms designer who joined Armalite in October 1954. Almost immediately, he focused on what would become his most ambitious undertaking. In 1955, the U.S. Army announced plans to replace the aging M1 Garand. The successor rifle had to chamber the standard 7.62 by 51 mm NATO cartridge, offer dependable performance and solid accuracy, and ideally weigh less than the roughly 9.5-pound Garand. Manufacturers across the United States and Europe responded. Springfield Armory proposed the T-44, essentially a refined Garand adapted to the new NATO round. Belgium's Fabrique Nationale submitted the FAL, already adapted by several European militaries. Both rifles followed traditional patterns: steel receivers, wooden stocks, and long-established gas piston systems. Each weighed close to 9 pounds. Armalite's entry, designated the AR-10, broke from convention. At just over 7 pounds, it was dramatically lighter than its competitors. Army evaluators at Springfield initially suspected an error in the documentation. A rifle firing full-power NATO ammunition was not expected to function reliably at such a low weight. Order rifles where the stock dropped below the bore axis. This straight-line configuration directed recoil rearward into the shooter's shoulder, minimizing muzzle rise. Its operating system was equally unconventional. Rather than employing a heavy operating rod like the Garand or a separate gas piston like the FAL, the AR-10 routed gas from the barrel through a tube directly into the bolt carrier group. This internal gas expansion system, often described as direct impingement, eliminated nearly 2 pounds of moving metal parts. Early evaluations were promising. Testers reported exceptional controllability during automatic fire. Combined with an efficient muzzle brake, the straight-line design allowed shooters to manage recoil from the powerful NATO cartridge with surprising ease. Accuracy was impressive as well, with groups under 2 inches at 100 yards, outperforming both the T-44 and the FAL. Initial reliability testing showed no structural weakness in the aluminum receiver. However, extended endurance trials exposed a critical flaw. The Army subjected the rifle to harsh conditions: prolonged firing without cleaning, extreme temperature swings, immersion in mud and sand. During one such test, the composite barrel, constructed with a steel liner encased in aluminum to save weight, failed catastrophically. The barrel ruptured, destroying the rifle. The official evaluation acknowledged the AR-10's innovative features, low weight, and controllability. Nevertheless, the Army concluded that resolving its deficiencies would require years of further development. In 1957, the service adopted the T-44, which entered production as the M14. Although the AR-10 was rejected, the setback proved instructive. In 1957, Armalite licensed AR-10 production to the Dutch firm Artillerie Inrichtingen. Fewer than 10,000 rifles were manufactured in the Netherlands over the following years, with sales to countries including Sudan and Portugal. Portuguese paratroopers who carried the AR-10 in African conflicts praised its precision and dependability. French Foreign Legion personnel in Chad, who obtained small numbers through indirect channels, described it as one of the finest combat rifles they had encountered. The design itself had not failed. Rather, it had arrived at a moment when American procurement favored conservative, familiar solutions. Meanwhile, the designer was already exploring the next step. Combat studies from World War II and the Korean War indicated that most infantry engagements occurred within 300 yards. At such distances, the full-power 7.62 NATO cartridge was arguably more than necessary. A lighter, high-velocity round could deliver adequate effectiveness while allowing soldiers to carry substantially more ammunition. In early 1957, the U.S. Continental Army Command issued new requirements for a lightweight rifle chambered in a small-caliber, high-speed cartridge. The response was a scaled-down evolution of the AR-10. It retained the straight-line geometry, aluminum receiver, modular construction, and internal gas system, but was redesigned around the .223 Remington cartridge. Originally developed for varmint hunting, the .223 fired bullets under 60 grains at velocities exceeding 3. First working model of the AR-15 was finished in May 1957. Equipped with a 20-round magazine, the rifle weighed about 6 pounds, roughly half the weight of the M14, which tipped the scale at over 9 pounds loaded. It was also more compact, measuring 39 inches in length compared to the M14's 44 inches. The design allowed both semi-automatic and fully automatic fire. Initial evaluations produced striking results. Tests indicated the rifle could pierce a steel helmet at 500 yards and penetrate a standard infantry flak vest at 300 yards. Its terminal performance drew particular attention. The lightweight, high-velocity .223 projectile tended to destabilize and fragment after entering soft tissue, producing wounds disproportionate to its small caliber. Despite these findings, the U.S. Army declined to adopt the rifle. The service had only recently standardized the M14 and showed little interest in introducing another platform, especially one chambered in what many officers dismissed as a small game cartridge. The Army's Ordnance Corps, responsible for weapons acquisition, resisted the design strongly. Some historians later argued that the resistance had as much to do with institutional pride as with technical concerns. Armalite had previously refused to grant the Ordnance Corps development control over the AR-10, fearing the concept would be shelved. By that point, the Corps had already invested its reputation in the M14 and had no incentive to reconsider. Armalite attempted to market the AR-15 abroad. Lacking its own manufacturing facilities, the company depended entirely on licensing agreements. Its parent company, Fairchild Engine and Airplane Corporation, decided to withdraw support. In February 1959, the production rights to the AR-15 was sold to Cults Manufacturing Company for $75,000 plus a royalty on each rifle produced. At the time, the transfer seemed unlikely to change the rifle's prospects. Colt possessed the design but had no confirmed military customer. The Army remained uninterested, and foreign sales were constrained. The AR-15 appeared headed for obscurity. An unexpected event in July 1960 altered that trajectory. On Independence Day, Richard Boutelle, then president of Fairchild and formerly head of Armalite, hosted a gathering at his Maryland farm. Among the attendees was General Curtis LeMay, Vice Chief of Staff of the United States Air Force. LeMay was already a prominent and controversial figure, known for directing the strategic bombing campaign against Japan during World War II and for transforming Strategic Air Command into a dominant force. His reputation combined operational brilliance with impatience for bureaucracy. Also present was Colt Representative William Mullen, who brought an AR-15 in hopes of demonstrating it to any interested officers. Learning that LeMay would attend, he arranged an informal test. Watermelons were placed at roughly 50 and 150 yards. LeMay examined the rifle briefly before firing, as about 100 rounds of 7.62 millimeters. Qualification data further suggested that 43% of AR-15 shooters achieved expert status in marksmanship tests, compared to 22% using the M14. By the end of the event, LeMay had reached a conclusion. Air Force security personnel were still armed largely with the M1 carbine, a World War II-era weapon considered inadequate for modern base defense. The AR-15 offered infantry-level firepower in a lighter, more manageable platform suited to mobile security forces. LeMay signaled his intent to procure 8,500 rifles and 8.5 million rounds of ammunition. However, the Army controlled small arms procurement across all branches of the U.S. military. Any Air Force purchase required Army approval. Having already rejected the AR-15, Army leadership showed little willingness to reconsider, particularly at the urging of the Air Force. General Maxwell Taylor, then chairman of the Joint Chiefs of Staff, advised President John F. Kennedy that introducing a second rifle caliber into the system would complicate logistics. The request was denied. LeMay did not abandon the effort. Over the following 2 years, he pursued one of the more persistent advocacy campaigns in modern U.S. weapons acquisition. Formal proposals were submitted, Pentagon meetings attended, and additional Air Force testing data compiled. The debate over the AR-15 had moved beyond a backyard demonstration. It had become a contest over doctrine, logistics, and the future direction of American infantry arms. He quickly asked for authorization to purchase 80,000 AR-15 rifles to standardize the weapon across the Air Force. The request was rejected. He did not stop. A second proposal was submitted, then a third. Each time, Army leadership intervened, maintaining that the M14 was superior and warning that introducing another caliber would complicate supply chains. Lame countered that the Air Force already operated different weapon systems from the Army in numerous categories. The dispute continued throughout 1961 and into the following year. At the same time, developments in Southeast Asia were increasing pressure for change. American advisors in South Vietnam reported that Viet Cong fighters equipped with Soviet AK-47 rifles were outperforming South Vietnamese troops armed with the older M1 Garand. The AK-47's intermediate cartridge concept was similar to the AR-15's 5.56mm round, lighter than full-power NATO ammunition, easier to manage in automatic fire, and well-suited to jungle combat. Requests began flowing in for field trials of the AR-15. In late 1961, McNamara authorized a limited evaluation. 1,000 rifles were shipped to Vietnam for testing by U.S. Special Forces and selected South Vietnamese units. The feedback was overwhelmingly positive. Soldiers praised the rifle's lightweight and compact dimensions, both critical in dense vegetation and close engagements. The small cartridge allowed troops to carry more ammunition on long patrols. Despite its size, the weapon proved highly lethal. Reports described severe wounds caused by the high-velocity projectile. In favor of the AR-15, to settle the dispute, McNamara ordered a comprehensive comparison between the AR-15, the M14, and the Soviet AK-47. The resulting Hitch report, released in the summer of 1962, dealt a serious blow to the Army's position. It concluded that the AR-15 outperformed the M14 across measurable categories. Troops armed with the newer rifle could carry more ammunition, demonstrated improved hit probability, and required less effort to maintain their weapons. Even more damaging, the study indicated that the M14 failed to surpass the AK-47 in meaningful ways. A rifle adopted only 5 years earlier at significant expense was shown to be inferior to its Soviet counterpart. The Army disputed the findings, conducting its own evaluations and criticizing the methodology. Nonetheless, McNamara reached a decision. In November 1962, he approved initial procurement of the AR-15 for the Air Force and Army Special Forces. Lane finally secured authorization, though not for the full quantity he had originally requested. The first shipment, 8,500 rifles, arrived in May 1962, nearly 2 years after his initial informal order. The weapon received a new designation, M16. Colt introduced several design adjustments, including relocating the charging handle to the rear of the receiver. Production expanded rapidly. The M16 was lighter, more controllable in automatic fire, and allowed soldiers to carry nearly double the ammunition load. It had passed official evaluations without serious issue. Then reports of catastrophic malfunctions began emerging in late 1965. In combat conditions, rifles were jamming. Spent cartridge cases failed to extract, remaining lodged in the chamber. In some instances, soldiers were discovered killed in action beside partially disassembled rifles, having attempted to clear stoppages under fire. Letters home described deep frustration and mistrust. Some Marines labeled the weapon a toy, an allusion to the toy company Mattel, suggesting it was unsuitable for real combat. Others resorted to picking up enemy AK-47s, risking disciplinary consequences in order to carry a weapon they believed would function reliably. Surveys conducted in 1967 revealed the scale of the problem. 80% of 1,585 troops reported experiencing stoppages during firing. A rifle intended to provide technological superiority had instead become a liability. The situation drew national attention. Designer Eugene Stoner traveled to Vietnam in early 1967 to examine the failures firsthand. His findings would contribute to a congressional investigation and expose serious shortcomings in the procurement process. At its core, the rifle's design was not fundamentally flawed. The problem stemmed from modifications introduced without adequate testing or consultation. One critical change involved propellant buildup. It created ideal conditions for failures, cartridge cases stuck in fouled chambers. When the bolt attempted high-speed extraction, case rims often tore off, leaving spent casings lodged in place. Clearing such a malfunction required inserting a cleaning rod down the barrel, an impractical solution during combat. A second issue involved the absence of chrome plating in the chamber and bore. Chrome lining had been recommended to resist corrosion, particularly in humid climates. Yet the Army removed the specification to reduce costs. In Vietnam's damp environment, unprotected steel chambers corroded quickly. Corrosion increased friction during extraction, compounding the sticking problem. Ammunition exposed to humidity developed surface oxidation as well, further aggravating reliability issues. Later congressional testimony identified the lack of chrome plating as a primary contributor to the crisis. The third factor was inadequate maintenance preparation. The rifle had been promoted as self-cleaning, creating the impression that routine care was unnecessary. Cleaning kits were not initially issued, and technical manuals were not widely distributed. Many soldiers deployed after only minimal familiarization firing, without proper instruction in maintenance procedures. In a climate where constant cleaning was essential, troops lacked both the knowledge and the tools to keep their rifles functioning. Its operating system directed hot propellant gases straight back into the receiver, which meant carbon residue accumulated quickly. Without frequent cleaning, that residue would build up and interfere with the weapon's moving parts. In Vietnam, this design characteristic collided with several compounding factors: the use of dirtier ball powder, the absence of chrome lining in the chamber and bore, and the region's intense humidity. The result was predictable. Rifles became heavily fouled in short order, and many stopped functioning altogether. For troops accustomed to the rugged dependability of the M1 Garand and the M14 rifle, both capable of operating with relatively modest upkeep, the new rifle demanded far more attention. In combat conditions, that difference proved critical. A particularly sobering case, later documented during a congressional inquiry, involved a Marine squad under intense fire. Only one Marine had been issued a cleaning rod. As rifles began to jam across the line, he moved from man to man, attempting to clear each malfunction. He was shot and killed while trying to free another Marine's weapon. Investigators later concluded that inadequate distribution of cleaning equipment had directly contributed to his death. Another controversial addition to the rifle was the forward assist. The original AR-15, developed by Eugene Stoner, did not include such a device. Stoner's philosophy was straightforward: if the bolt failed to close under its own power, the shooter should address the underlying issue rather than force the action shut. Indicated that forcibly closing the bolt could trigger extraction failures. Those findings were not given proper weight. By early 1967, reports of malfunction had escalated into a national controversy. Families contacted lawmakers. Major newspapers questioned the reliability of the rifle. The narrative emerging from Vietnam was deeply troubling. American soldiers were being placed at risk not solely by enemy fire, but by mechanical failure. On May 15, 1967, Representative Richard Ickhold convened a special House subcommittee to investigate the rifle program. Hearings ran through August and involved extensive testimony. The final report, issued on October 19th, stretched to nearly 600 pages and stands as one of the most severe critiques of military procurement practices in U.S. history. Stoner testified that substantial alterations had been made to his design without his involvement. He argued that when paired with the correct IMR powder, chrome-lined components, and proper maintenance, the rifle performed at a level equal to any contemporary service weapon. He produced documentation showing that chrome plating had been recommended from the outset, and presented test data demonstrating reliable function with appropriate ammunition. Representatives from Colt's manufacturing company supported these claims. They stated that concerns about ball powder had been raised early on but dismissed. Company records indicated that chrome lining had been advised, only to be removed from specifications as a cost-saving measure. Internal memoranda revealed that extraction failures had been anticipated months before widespread reports emerged from Vietnam. Under questioning, Army Ordnance officers conceded that the ball powder had not undergone adequate evaluation prior to approval. Some acknowledged that the rifle had been described as self-cleaning despite a lack of evidence. A few officers also disclosed personal reservations about the new rifle, expressing preference for the older M14. The subcommittee's conclusions were blunt. It attributed the malfunctions to mismanagement, insufficient testing, and neglected logistics. Critical design elements had been altered without rigorous validation. Necessary maintenance equipment and training had not accompanied the weapon into combat. Warnings from both the designer and manufacturer had gone unheeded. The language of the report suggested that the failure to correct known issues approached criminal negligence. Corrective measures followed rapidly. Chrome-lined chambers and bores were put into production. Ammunition specifications were revised to incorporate improved powder. Millions of cleaning kits were manufactured and shipped to Vietnam. The Army produced illustrated, comic-style manuals to instruct soldiers in proper maintenance and implemented mandatory training focused on the rifle's care. A series of 10 design changes culminated in the standardized M16 Aeon, formally adopted on February 28, 1967, replacing the earlier XM16 Aeon designation. With these adjustments in place, correct ammunition, chrome lining, proper equipment, and trained personnel, the rifle's performance stabilized. By late 1968, malfunction rates had declined to levels comparable with other service rifles. Soldiers equipped with the updated M16 Aeon often regarded it as a highly effective combat arm, lightweight, accurate, and controllable. When maintained correctly, it proved dependable. Its advantages became increasingly evident in Vietnam's close-range engagements. Troops could carry roughly 300 rounds of 5.56 mm ammunition compared to about 140 rounds for the M14. The lighter load improved mobility, and the high-velocity projectile demonstrated substantial lethality against opposing forces. The M16 Aeon remained in service through the end of the Vietnam War and was adopted across all branches of the U.S. military. During the 1972, numerous Allied nations incorporated it into their arsenals. Production climbed into the millions during the following decade. The platform continued to evolve. The M16 ATWO introduced a heavier barrel, refined rear sights, and a brass deflector to accommodate left-handed shooters. In the 1992, the M16 AFR featured a flat-top receiver with a Picatinny rail for optics. In 1994, the military fielded the M4 carbine, a shorter configuration with a 14.5-inch barrel and collapsible stock. Over time, the M4 supplanted the M16 in many frontline roles. Despite these refinements, the core principles established in the original design endured: a direct gas operating system, a straight-line stock layout, extensive use of aluminum components, and modular construction. What began as a troubled introduction ultimately matured into one of the most influential rifle platforms of the modern era. The engineering ideas that took shape inside a modest garage in Long Beach during the 1952 continued to shape American service rifles for decades. Yet Eugene Stoner's work did not end with the AR-15. When Armalite transferred the AR-15 rights to Colt in 1961, Stoner stayed on briefly as a consultant before moving to Cadillac Gauge. There, between 1962 and 1963, he created the Stoner 63, a highly modular weapons platform that could be assembled as a rifle, carbine, or light machine gun depending on operational needs. Though only about 4,000 units were produced from 1963 to 1971, the system saw combat in Vietnam, particularly with U.S. Navy SEAL. Despite its ingenuity, it never matched the widespread adoption of the M16. In 1971, Stoner helped establish Ares Incorporated in Port Clinton, Ohio. At Ares, he refined earlier concepts, producing updated variants such as the Stoner 86. He also explored ideas that were well ahead of mainstream military thinking at the time. Among these were polymer-cased ammunition to reduce carried weight, telescoped cartridges designed to increase magazine capacity, and caseless ammunition systems. Considered overly ambitious in the 1970s, these experiments anticipated developments that would reappear in small arms research decades later. At age 67, in 1990, Stoner joined Knight's Armament Company in Titusville, Florida. There he designed the SR-25, essentially a scaled-up AR pattern rifle chambered in 7.62 by 51 mm NATO. The platform blended precision rifle accuracy with the ergonomics and reliability associated with the M16 family. The U.S. Navy adopted it as the Mark 11 Mod 0 sniper system, and it later saw service in Iraq and Afghanistan, where operators commended its performance. The SR-25 demonstrated that the original AR architecture could be successfully adapted for larger calibers, an idea Stoner had explored decades earlier. That same year, Stoner met Mikhail Kalashnikov, creator of the AK-47, for the first time in Washington. For decades, their rifles had equipped opposing forces across the globe. During their meeting, they toured the NRA's National Firearms Museum, examined each other's firearms, visited Marine Corps facilities at Quantico, and even tested one another's designs on the range. By most accounts, mutual respect quickly formed between them. Each had pursued solutions to similar battlefield challenges, though guided by different design philosophies. Kalashnikov emphasized durability and mechanical simplicity. Stoner prioritized lightweight and accuracy. Both approaches proved enduring. Became the most widely produced American military rifle. Stoner never amassed significant wealth. His royalty arrangements were limited, and he spent most of his career employed by companies rather than leading them. The AR-15 platform, however, grew far beyond its military origins. More than 30 million civilian semi-automatic variants are now privately owned in the United States. For some Americans, it represents constitutional gun rights. For others, it symbolizes gun violence. Several states have enacted restrictions or bans on AR-15-style rifles, and public debate remains deeply divided. Members of Stoner's family have said he designed the rifle for military purposes and would have been distressed by its association with mass shootings. Others contend he likely would have supported civilian ownership, citing his involvement in commercial firearms. His personal stance is ultimately open to interpretation. What is not disputed is the rifle's military impact. The M16 family has served in every major U.S. conflict since Vietnam, including operations in Grenada, Panama, the Persian Gulf, Somalia, the Balkans, Afghanistan, and Iraq. More than 80 countries have adopted variants of the design, and licensed production has occurred in nations such as South Korea, Singapore, and the Philippines. Numerous rifles, including Taiwan's T-65, Canada's C-7, and Britain's L-85A1, reflect direct lineage from Stoner's original system. The introduction of the M16 also reshaped infantry doctrine. Because 5.56mm ammunition weighed less than 7.62mm NATO rounds, soldiers could carry substantially more ammunition without increasing their load. That advantage influenced everything from squad-level tactics to supply planning. From a small workshop in California to battlefields across the world, Stoner's design principles reshaped modern infantry warfare. His legacy remains both influential and contested, defined by technical innovation, global adoption, and ongoing public debate. The adoption of the rifle transformed the operational endurance of infantry units. Troops were no longer as dependent on frequent resupply, even during long missions conducted far from logistical hubs. This logistical advantage proved decisive. Because the weapon was lighter and its ammunition more compact, soldiers could carry significantly more rounds without increasing their load. That shift enabled the development of modern air assault doctrine. Helicopter-borne units could deploy into remote areas with sufficient ammunition to sustain extended firefights, something far more difficult with older, heavier rifles and bulkier cartridges. A key technical feature of the design was its direct gas operating system. Though some engineers continue to favor piston-driven mechanisms, most contemporary service rifles rely on variations of the same gas principle introduced in this platform. When properly maintained, the system demonstrated an effective balance of reduced weight, mechanical simplicity, and consistent performance. Assumptions about materials and rifle construction, he questioned them. He explored lightweight alloys and alternative design philosophies that many experts initially rejected. His success came from challenging accepted norms and persisting despite skepticism from established authorities. Opposition from within the Army's Ordnance establishment was intense. Senior officials, many highly educated and experienced in weapons development through 2 global wars, were confident that a self-taught designer could not surpass their understanding of rifle engineering. Their resistance delayed acceptance and contributed to serious consequences once the rifle entered combat in Southeast Asia. The crisis surrounding the M16 in 1967 stemmed not from inherent design flaws, but from institutional decisions that altered key specifications without fully grasping their impact. Changes to ammunition and maintenance protocols were implemented, despite warnings from the original design team and manufacturer. The resulting malfunctions in the jungles of Vietnam had deadly implications. A subsequent congressional inquiry determined that responsible officials failed to correct known problems and that their inaction approached criminal negligence. Nevertheless, no senior figures were formally punished, and the broader culture within procurement institutions remained largely intact. Reforms followed, and acquisition procedures improved. Even so, the broader lesson that innovation may originate outside traditional hierarchies and that expertise should be evaluated on merit rather than credentials has repeatedly proven difficult for large organizations to internalize. Many civilian owners of AR-15-style rifles are unfamiliar with him, and countless soldiers who carried the M16 during the Vietnam War never knew who engineered it. Throughout his life, he remained reserved and technically focused, preferring workshops to executive offices. Public recognition mattered little to him, engineering refinement did. Journalists who interviewed him encountered a measured, technically minded individual, more interested in discussing tolerances and mechanisms than in claiming personal credit. Yet the enduring influence of his work is unmistakable. Gun retailers across the United States display numerous AR-15 variants. Military installations train recruits on the M4 carbine, a direct descendant of his original architecture. Infantry manuals worldwide assume the presence of lightweight, high-velocity rifles built around concepts he pioneered. Over time, the platform became the benchmark for modern service rifles. Competing designs are routinely evaluated against the standards established by the M16 family. Production figures illustrate its scale. Roughly 8 million M16 rifles have been manufactured for military forces globally, with millions more M4 carbines produced. In the civilian market, over 30 million AR-15 pattern rifles have been sold in the United States alone, making it the country's most widely owned rifle platform. The design has been manufactured in more than a dozen countries, fielded in over 100 conflicts, and adopted by armed forces in more than 80 nations. Introduced a new rifle, yet full replacement of the M4, if it occurs, will require many years. For the foreseeable future, the M4 remains central to American infantry capability. Stoner's career demonstrates that transformative innovation does not always originate within established institutions or academic pathways. He showed that formal credentials are not the sole route to technical achievement, that established doctrine can obscure better solutions, and that unconventional materials and design strategies can redefine accepted limits. Though he did not live to see the full global impact of his work, the durability of his rifle family suggests that sound engineering can ultimately prevail over bureaucratic resistance. A weapon once dismissed as impractical became the defining rifle of contemporary infantry warfare. A machinist without formal engineering credentials produced a system that specialists continue to refine but rarely surpass. From modest beginnings in Indiana during the Great Depression, Eugene Morrison Stoner left behind a design that reshaped military small arms. The path from private workshop to global standard was long and marked by controversy, investigation, and institutional conflict. Yet the final outcome remains clear. The rifle, once deemed unrealistic, became, against expectations, America's enduring service rifle.